Hey developers! The other day I was looking around for more information on Web3. And while I was looking around, I actually found out there isn't many resources on using Web3, the tools and technologies with it, and using Vue.js on the front end. Most of the tutorials I found actually only used React, so I thought it'd be fun to show you how to use Web3 with Vue.js on your front end. We're also going to look at some other technologies, Polygon. We're going to create a Solidity contract. We're also going to create a really cool Guestbook app that you can sign your name in and actually earn coins back if you win. So we're going to look at that all in this video today, so make sure you stay all the way to the end. But first, I want to answer the question you're probably thinking, what is Web3? So I'm going to go ahead and borrow a definition from Nader Dabit, who explains that Web3 is the stack of protocols that enable fully decentralized applications. And they have some characteristics that a lot of them share, including they have a decentralized web infrastructure, they have this ownership that's of data, content, platform, they have native digital payments, they have self-sovereign identities, they're distributed, and they're open and public. Essentially, in a lot of ways in Web3, you end up owning the data with it. So we can't talk about Web3 without talking about some more of the technologies that make it up. So there's things like blockchain, file storage, blockchain development, peer-to-peer APIs. But what we're going to use in this tutorial today is we're going to use the Polygon network, which they call a level 2 chain that's off of the Ethereum network. We're going to be using Hardhat, which is going to help us create our contracts that we're going to be using. We're also going to be taking a look at Ethers. So we're going to use a lot of these different technologies to create our decentralized app. Before we deep dive into the Vue application and all the code, I wanted to explain a little bit about Solidity. Now, Solidity is an object-oriented, high-level language for implementing smart contracts. And smart contracts are programs which govern the behavior of counts within the Ethereum state. In this case, we'll be using Polygon. So this is the way that we're going to create applications that run on the blockchain, and we're going to be able to interact with those contracts to do things. In this case, I decided that we're going to create like a guestbook. So to make that process much easier, I actually found this website. It's called remixethereum.org, and it allows you to create contracts, test them out inside the browser, or connect them up to your own wallets, which we'll explain a little bit later. And this allows us to create our contract. And I'm going to explain the contract I'm going to be using for this tutorial. The one I'm using is called Wave Portal. I have actually Googled it, and it's used in a bunch of different tutorials out there. It's a real basic way of creating a guest book online, but I kind of wanted to make it my own, so I made some additions and changes to it, which I'll explain here. So what I did first is this guest book has you have to pay to actually post, which is a small amount of what's called Matic, which since we're using the Polygon network to post, and randomly you'll actually win some of that money back, which I think would be very interesting. The way I started off with this is you can just go to remix.ethereum.org, and on the left hand side there's this contracts, and you can just go and add your own contract. I just right clicked on it, went to new file, and I created this waveportal.sol. Now I'm going to explain the basics of this contract. I'm not going to type it all in. If you're looking for a more in-depth tutorial on Solidity, I'll put a link here. There's a whole bunch of really great tutorials on it. Just check those out. But essentially what we're doing here is it's a very object-oriented programming. So if you're familiar with Java or C#, you should be feeling very at home with this. But we have this struct here. We have a contract, which is sort of like a class, which holds all the information we need. We can import stuff in too, like I imported this Hardhat in package. And you also have these different versions. I'm just gonna use 0.8.0. And so structs are kind of like objects right here that have our information we wanna save. This thing right at the beginning is the type of object. This is an address, which is the address of the user who waved. We have the message, we have the timestamped, and then we have events, and events are kind of neat. Events are a way that they don't actually get written to the blockchain, but you can listen for events inside our Vue application and then do something when they get emitted. So we could subscribe to them using what we're going to use on our front end, our Ethers package, our front end library. And then we have a constructor, and remember in object-oriented programming, constructors are ran as soon as the class is instantiated. So in this case, as soon as this contract is instantiated, this constructor will run, and it sets the owner as basically whoever created it will become the owner. And also you can create these modifiers that you can add on to your different functions, which kind of actually are gatekeep it, so only owners can do things with it in this case. And then so I have some basic functions here. You can withdraw out of it, but you can only withdraw if you created the contract. We have a balance, so you can get the balance. We have waves, which basically gets all the messages. And then we have this pretty complicated wave function. And what this does is you can, once you have this wave, you can send a message to it with the message, the string, and it creates the message and adds it to the blockchain. So this random number is the way we're kind of doing the prize aspect of it, where if your random number is less than 50, which you're sitting at 100, then you win 0.5 Ether, which in this case will be Matic, but it's Ether. And then we also emit a message. And we have this sender where we call back, where we basically send that the prize amount was sent. Now that's just a quick high-level overview of this contract. Like I said, if you want to deep dive into Solidity programming, it's pretty complex, but you can see that in separate videos. One other thing I want to show you is we can actually run this thing. So to run it, we need to click on this button here. It's going to tell us the compiler, Solidity. Now for right now, we are going to use this 0.87, but we can obviously do all the way to 0.80. Let's compile it. You click the compile wave portal button, and if I did everything correct, it should compile, which it didn't give me any errors. And now if I come here, this next tab down, this is where it shows me the actual how to test it out. So I have this JavaScript. I'm going to use it just the local JavaScript virtual machine. It gives you an account with some fake Ether in it. So I have 100 Ether in there. I have a gas limit and a value. So I can click deploy here. Cool. So when it said it went ahead and deployed for me. And remember, this is just a virtual VM on the JavaScript VM. And now if I look down here, I have a bunch of the methods that we had inside that contract, like wave. We have withdraw, get all waves, get balance, owner, total count, wave count. So if I click here, you can see it says 0. It might be hard to see, but it says 0 there. But if I try to put in a wave message, I click wave, it looks like it failed. And the reason it failed is if we go back to our wave, we actually have this exact amount, which is 0.05 Ether, which I have, this require here basically says you have to send 0.05 Ether, otherwise it'll fail. Before we actually test this out, I actually saw one little bug here that I wanted to change. The prize money is 0.05 Ether, but this actually may not have enough money in it. So I'm going to change this so it's every less than 5, so it happens less often. I'm going to put right here 0.5, and you can mess with these numbers. I'm going to save it. I'm going to click deploy. So now it's deployed again, and I have it here. So let's see if we can test it out. I just need to make sure I send 0.05 Ether. So I have this website that I found that does conversions of Ether, and these are basically fractions of Ether for GUI. So I'm going to put 0.05. I'm going to copy and paste this GUI into where it says right here value. And now I'm going to try this. I'm going to do hello world. I'm going to hit wave. Cool. So it said it went through. And I can do this if I do get all waves. You can see here is the tuple. It's kind of hard to see, but it says hello world. So the message did go through. If I get balance, you can see there's at least this 50,000, 50 million, probably higher than million, but 5 many zeros at the end. If we click on owner, we can see that's the address of this owner, 5B3, which is this one. Total wave count, you have 1 in there. And if I want to, I can withdraw all the money. If I click withdraw, it withdraws it back into this contract here. And now if I get balance, it's 0. So you can see it's all working as we expected. And so you can, as long as you pay, you can add messages to this message book that we have. And we can also withdraw money out of it if we're the owner. And then occasionally someone will win money from it. So let's take a look at how we would set this up in our development environment. So to get started with this, before we deep dive into the code, we want to set up a crypto wallet, which will allow us to receive and send money to our application that we're creating. In this tutorial, we're going to use Metamask. It's one of the most popular ones. If you go to metamask.io, click the download button and it'll install as an extension into your browser. After you do that, we need to go ahead and add some money to it and set up the test network. So we're not going to be using the actual Polygon production network out there. We're going to use a test network. That way we don't lose real money. If you are wanting to use it on the real network, you can use things like Coinbase or Crypto.com, and you can buy Matic on it. And if you are going to buy Matic, I would highly recommend it to buy it on Crypto.com, because it actually, if you buy Matic on there, it'll be on that network, on the Polygon network. There's a few ways of doing this, and I've seen a lot of different tutorials, and some of them actually connect up to the test network directly. But Alchemy is 100% free for a certain amount of transactions, and it's, for our purposes, it's really easy to start with. So I created a free account on Alchemy, and you can find that at alchemy.com. Once you're into alchemy.com, you'll have a dashboard. It sort of looks like this, and you can click this Create App button. And then inside here, you can put whatever name, test network, and you can choose your chain. In this case, we're choosing Polygon. And one of the reasons I'm choosing Polygon too, because the gas fees are really cheap. Basically, anytime you want to send or receive transactions on any of these networks, there's a fee associated, and the fee is lower, and we call that gas, is lower on the Polygon network. And you can see here is Polygon mainnet, but if you do Polygon Mumbai, this is the test network. And you click Create App, and it'll go ahead and create it. In this case, I already created it here. You'll see here, I actually ran some transactions on this earlier, but you can click this button that says Add to Wallet. If you click Add to Wallet, your Metamask will open up, and it'll ask you if you want to add it. You click Switch Network, and it'll go ahead and do it for you. So I would highly recommend for everyone who is following along this tutorial, sign up for a free account through Alchemy, and then add this wallet to your Metamask. After it's installed, you can then choose the Metamask Mumbai network if you click on the little count button at the top. And right now you'll probably see 0 here, but this is the amount of Matic that you have in your wallet. Now what's really cool, since it's a test network, we can click this button here. It'll copy to the clipboard. There's a website created by Polygon called faucet.polygon.technology. And you can choose the Mumbai network, and you can just paste your address in here and get free Polygon Matic tokens into your wallet. And you just click Submit here, confirm, and then it just takes 1 or 2 minutes, and it'll add about a half a Matic token into your wallet. And so I would do that a few times to have some extra free tokens inside your test network wallet, because we'll be needing to use that during our tutorial. Okay, so for our app today, we're using Vue 3, but I thought it would be interesting, and since I mentioned this in my previous video, if you haven't seen it, check it out here where I talk about different ways to start your Vue apps, that you can use Vitesse to start your app. Now this has Vue 3, it has Pinia, it has Tailwind, all built into it. It's a template you can use real quickly. So we're going to use this to help speed up our development time. So I'm going to click this button. If you go to github.com/anfu/vitesse, I'll include a link in the description. And by the way, I'll also include a link to this whole app inside there as well. If I click use this template, it's going to ask us the repository name. So I'm going to do Web3 Vue test YT. I'm going to create repository from it. And what this is going to do is it's going to basically clone it into my own workspace, into my own GitHub profile. And now I should be able to use this. So I'm going to click code. I'm going to grab this clone here. I'm going to do glit. Let's go ahead and clone it. We'll do git clone. I'll copy and paste it in there. And this will go ahead and clone into the folder. And I'll go ahead and change directories into it. So let's go ahead and install a few dependencies that we need. I'm going to copy and paste this from another monitor, but basically we're going to install Ethers, Hardhat, Hardhat Waffle, Ethereum Waffle, Chai, Nomac, Hardhat, Ethers, essentially everything we need to be able to have our Vue application, be able to talk to our Solidity contract, be able to compile our contract and deploy it. Okay, so we have all our dependencies installed. So we'll run npx Hardhat, and this will go ahead and install our basically a sample project so we can take our Solidity contract and put it inside there for us to deploy. So I'm going to create a basic sample project. I'm just going to hit enter through all this. False. And that should be it. It went ahead and added everything in, and now we should be able to go ahead and add some code in. Oh yeah, I forgot. One more thing you need to install. Do npm install .env, and that'll install .env, which is going to a way for us to hide our secrets. I went ahead and did that already. So let's take a look at our app. So if you can see here on the right-hand side, we have a bunch of folders. We have some new folders that Hardhat created for us. One called contracts, where we're going to store our contracts. We have this scripts folder. But one thing I want to show you first, and I have this package.json, of course. But one thing I want to show you first is our Hardhat config file. So if you look in the right-hand side in the root, there's hardhat.config.js. Go ahead and open that up, delete everything in it, and we're going to start from scratch here. So what we're going to first do is we're going to add this module.exports. And of course, we're going to use this required.env, which you just installed. And we should have this Hardhat waffle that you installed as well. And by the way, if you missed the last step, we install all these dependencies. Just check your package.json, make sure you have them all in. And you can also use yarn or pnpm, whatever. I'm just using npm because it works. So I'm going to put Solidity version 0.84. And then I'm going to put some paths in. So source artifacts is what I'm going to choose. So anytime the artifact gets compiled, it'll put it in this folder, which is our contract. We're going to set up a network for Hardhat, which is going to be our local one. We're not going to use this in this example, but if you need to, it's there. We're going to use the Mumbai network, and we're going to have an address here. And the way you want to get that address is go back to Alchemy. And when you're logged in here, you can click on View Key. This will go ahead and give you the HTTP key for the Mumbai network that you should use. So go ahead and copy and paste that and add it in to this URL here. And then for the accounts, this is actually going to be your private key. So you'll actually need the key inside your Metamask. So if you go into your Metamask and you can click down right here and you can go to account details and you can click export private key. I'm not going to do that on camera because it's something you never want to share with anyone. Essentially, if someone has your private key, they can go into your wallet and steal everything out of it. Then come back over to your app, create a new file in the root. I went ahead and did that called .env and create something called private key and go ahead and copy and paste it inside here and it'll go ahead and be there for you for the app to be able to push this to the network it needs to go to. Next thing we need to do is actually create the contract. So go ahead and go into the contracts folder, delete everything inside of it, and we'll create a new contract called Wave Portal. And inside the Wave Portal, let's just copy and paste this contract. And if you're following along, make sure you just grab it from the GitHub repository in the description, and you can do that there. So I'm just going to grab it, I'm going to paste it. And this is exactly what I showed you in the earlier section. This has the same everything that we had before, and it pays out, I put 0.5 Ether, and it costs 0.05. I'm going to change this so it's less than 5. So it doesn't keep continuously trying to, it won't continuously try to pay out, that is. So I'm going to save it here. And the next thing we need to do is see if we can actually deploy it. So open up the deploy.js file. It's in the scripts folder. And we're going to add in a deploy script to get our contract that we just copy and pasted onto the Polygon Mumbai network. So first I'm going to require Hardhat. By the way, if you don't require Hardhat, I did this in the past. It gave me a whole bunch of errors. So make sure you add that to the top of the file. We're going to create an async function main. We're going to create a deployer, which is going to, basically this allows us to get the correct signers so it can deploy correctly. We're going to just do a console log here of the address because we'll need that later on. We're going to do a wave portal, which I guess you can't see very well, which is this wave portal here creates the contract. We're going to deploy the contract, and we're going to call something called .deployed. And right down here, here's our main function that all it does is it just prints any errors out. So that's all it is. There you may have seen a greetings or a sample script file in there. This is very similar to that. It's just that we've kind of changed it all to use this wave portal contract that we have. So we'll go ahead and save it. And the next thing we need to do is to try to see if we can deploy it. Okay, so we are ready now to deploy this and to compile the contract. So first we need to compile the contract. So we'll do npx hardhat compile. And this will go ahead and compile the files. It'll also put them in the right folders. So if you remember correctly, from earlier, we told it to go into the source folder artifacts. So here it is, created all these folders, and it has this ABI code, which we'll need for the Vue app to actually interface with the contract. So we'll go ahead and deploy it now. We'll do npx hardhat run scripts deploy.js -- network Mumbai. And if we did this correctly, it should go ahead and deploy it. And since we are using the network, we put that private key in, it should take some money out of our wallet that we'll see in a second, and it should deploy. So let's just take a moment. Cool, so went ahead and deployed, and we just need to make sure that we copy this web portal deploy down. We'll need that later on, so make sure you copy and paste that somewhere. The next thing we want to try to do is actually create a store, a Pinia store that has all our crypto functions in it. So this is going to interact with our contract. It's going to send the wave over, so basically send the message to create the guestbook posting. It's going to interact with it, and we're basically one place. Now we could put this in its own utility file somewhere, but I think I like it in Pinia better because it's all in one place and it's easily shareable throughout the whole app, and we can use ref and reactive to be able to have these values not be lost. So to do that, go ahead and open up the stores folder, create a crypto.ts, and if you like, also take a look at the code in the GitHub repository linked below, and you can see it through there too. I went ahead and created this file. It's empty, but let's take a look what should be in it. So first, Ethers is the JavaScript library. I find it really easy to work with. This is what's going to power our front-end library to talk to our contract on the blockchain. Then we're going to have some Pinia stuff in here. By the way, don't worry about it, the squiggly lines right now. It's just because we haven't gotten this all done yet. We're going to have an artifact. So this artifact line, this is actually in here. So if we go to artifacts, so ... artifacts, which is right here, contracts, wave portal, .json, here's this file. It needs this. This is basically the contract file that it needs to have. In fact, it needs the JSON file, and that file will be used throughout this app, and it'll be used to contact and talk to the contract. And then this address right here is the same address that we copied and pasted before. So when we ran and deployed the contract, it gave us that address. Make sure you copy and paste it and put in here where it says contract address. And this is import meta. Don't worry about that. That's something to do with the hot swappable stuff. But that's just basically inside this Vitesse template. Now we're going to create this use crypto store. We're going to be able to import this in our files. So first I want to have an account. I'm going to use a reactive count. I'm going to use guest posts, create loading, which our guest post count. So the first function we're going to create is get balance. And we're going to create something called set loader in a second, but I'll just leave it there for now. So as soon as you try to get your balance, it's going to put a loading page on. We're going to have this try catch box. Now, since we're using Metamask, it actually adds Ethereum as an object onto the Windows object, so we can destructure and grab it. Obviously, if this fails, then he'll hit the catch block. So if Ethereum is there, we're going to create a new Ethers providers Web3 provider Ethereum. And this, what'll happen is it'll actually, and I'll show you after we have this all finished, it'll actually, it'll bring up a box in MetaMask that'll ask you if you want to connect to it. So that's part of this library and how it connects with MetaMask. We'll get a signer from it. And this is where we'll create our contract. Remember where this contract is here, this contract ABI? Well, we can grab this contract ABI and with the signer and the contract address, and now we can run with this wave portal contract all those methods that we have, which is really awesome. So now if I want to grab the count, I can await it. You can do async await. I can do get balance. That's the same thing that's inside our contract. So if we go to our contracts again, remember we have one called get balance right here. So that's the same thing we're calling right here to get it, which is awesome. We can, there's some utilities with this Ethers library, so we're going to format it so it looks correctly. We're going to console log it. We're going to set loader false. And now we're going to go into a wave here. So this is the main bulk of our code here. And this is going to allow us to actually send inputs in. So this message input is a string, and we're going to be able to send it in. So I'm going to do a try catch block again. Once again, I'm going to check to see if this Ethereum is there. And I could probably refactor this out to its own utility library so I don't have to kind of copy and paste the same code twice, but it's just a couple lines. Once again, we have to do the same thing here where we grab the web provider. We have to get the signer. We have to get the contract again, the same way we did before. And now we can actually do, this is really cool. You remember how I told you that there's events in this wave portal that we created? Like this event new wave, event prize money sent. We can actually listen to those events using the contract and this on. So it's kind of like a subscription that you can use to, it'll only be triggered when this prize money is sent. So I can do a console log that it received it. So all I'm doing is a console log for it. And then I want to create an override to say that we know this function wave here can only be called if they have the right amount of value. So what this says is that go ahead and send over 1 ether, or this 1/2 ether, 0.05 ether over, and put the gas limit at 20,000. Now this gas limit might change depending if you're actually on the normal Polygon network. Remember, the gas is like a fee that you have to pay, and you can put it in here so you basically market how much gas you want to be able to send. So I put 200,000. I think this is in Gwei. So now we're going to actually do the smart contract execute. To do that, we do this wave portal contract.wave, and then you put the message input and then the money. Once we're going to be sending over 0.05, that's the transaction. We're going to await it. So we have to wait it again. So it takes a little bit of time for it to execute and for the blockchain to acknowledge it. So we'll just wait on that. And then once it's done, we'll just console log it out, and then we'll get the count again. And then we'll go ahead and console log the count. We'll set the message input back to nothing, and we'll set the loader to false since we're not loading anymore. And then I just have some catch blocks here to do everything. Now here is how we're going to get all the waves. So we're going to set up another try catch block. It's going to be somewhat familiar. We both have the Ethereum. We have to get the provider and the signer again. So as we did before. Now we're waiting to get all waves. Once again, if you look at our contract, we have something called, if we look here, get all waves, get all, this one right here, and all it does is it returns the waves. We basically only need the address timestamp, so we're going to kind of go through each one of them and format them the correct way. I have some comments in there. So I'm using this new international date time format, and I'm just formatting the date time the correct way so it'll show up correctly as ENUS. And then I'm pushing it all into this new waves cleaned, which is this object here. We're going to set this guest post.value. Remember, this is a reactive variable. So we're going to set it to this new waves cleaned. And that should be it. And we have this new wave. Anytime someone adds a new message for our guestbook, this event will be triggered. And we'll just go ahead and make sure that we take basically did everything we did before. Once again, I probably could have put this in its own function, but just for simplicity's sake, I left it like this. And I'm going to take the guest post value, and I'm just essentially taking everything that's in it and just adding this into it. I guess I could have used push as well, but I don't know. At this time, I thought this was better. And then once again, if nothing's there, it just kind of throws an error message for you. And get wave count's going to be similar to the last ones. Remember, same thing we're doing is we're checking the Ethereum on the window. We're grabbing the signer, and this time we're running total wave count. And then we're just setting that to this guest posts count, connecting it. Now, we want a way for someone, as soon as the wallet opens, or as soon as the web page opens, to click a button to connect. So we're going to kind of have this connect wallet call everything else. Once again, if you don't have Ethereum at all, it's going to give you an alert message. And we're going to do this new thing called Ethereum.request, which requests the accounts. This is going to connect the wallet. It's going to grab the first account, and then it's going to run the wave count, get all the waves, and get balances. And that way, as soon as you press this button, it's going to load everything. And we'll have this error message, and then the set loader we've been referencing throughout the app. This is what this is. It's just a simple variable that we can use to either show a timer, basically a loading spinner, or not. And then we have to return all these because we're using Pinia, and it's an object. And yep, that should be it. So this is our crypto.ts file that defines the store. All right, so next up is we want to create a index file, and we're just gonna have one route. It's basically the main route, and it's going to display all these messages, allow us to connect to the wallet, and also be able to send information. Go ahead, and if you open up the pages folder like I did here, just open up the index.vue, delete everything out of it, and we're gonna start from scratch here. So first, we're gonna obviously do script setup since we're using Vue 3, and we have language TypeScript. I'm gonna import in something that's stored to refs from Pinia. We need that. That's a way to do some destructuring. We're gonna get our crypto store that we just created. We're gonna use this message input, which is going to be on our input, kind of like a V model. We're gonna grab the crypto store. We're going to grab out Wave and connect wallet out of it. And we're gonna use this store to refs, so you can't destructure directly out of the crypto store. So we use the store to refs to get these out of here, or at least we can't do it for these type of ones right here, this account, guest post account. We can directly use these functions, but not these reactive variables. That's why I use these store to refs. If you're confused about this, I did a whole video on Pinia a while back. You can check that out. All right, so now we have everything in place. Let's create our template. So we're gonna use some Flex here. So we're using Tailwind CSS. Remember, that's one of the reasons we're using Vitesse, this template, because it has it built in. We didn't have to install it. And essentially we're using Flex column. We're centering this. We're gonna put a big message at the top that says Erik's Crypto Guestbook. Then we're gonna create a button that only works if account is true, not there. So if we already connect to our account, this account will be true and this won't show up, so you can't connect to it twice. And we're gonna have some rounded corners and things like that. And then if the account is there, then we're gonna allow them to have this input, and we're gonna do a V model to this message input. And then we're gonna have a button that says send, and that's just gonna run this wave. And remember, we're grabbing it from the crypto store, and that's going to connect to our wallet and do the wave, which is exactly what we want. And by the way, when you click the connect wallet, it runs connect wallet, which also connects to the store and does everything we need to do to grab into Metamask. And then we're simply going to take this guest post, we're gonna show the number account, and we're just gonna show all the different messages inside of it. And then the timestamp and the message. And that is really it. It's really simple on this side here. Since we did all the hard work inside the crypto store, this is not too bad. So I think we have everything together. Let's go ahead and run it and see if it works. Oh yeah, there's one more component that we need to create, and that's the loader component. And so this component will load and create a spinner. So I'll show you real quickly how that works. We need to change a couple of files. First, we're gonna create this style tag in this new loader.vue, and you can go ahead and add this to the components folder. And I'm just gonna have some WebKit keyframes for the spinner. So it's gonna rotate the spinner around 360 degrees. And then I'm gonna create this loader class that just does a little bit of different colors, has this spinner on it. And then inside the actual HTML, I'm going to put in this loader, EaseLiner. This is basically a Tailwind loader. I'm not gonna get into too much of the code, but I'm just gonna have it text white. It's gonna have loading. It's the width 1/3, and it just says, please take a few seconds, please don't close this page. And now since we have this loader component, we can actually use it in this app view here. And by the way, since we're using Vitesse, we don't actually have to import it into this app view. It just automatically exists. What I did here is I went ahead and grabbed use crypto store off camera here. I added this line in, use crypto store. I'm grabbing the props from it. I changed the name to Erik's Crypto Store. And then I put props.loading and then loader.vif props.loading. You don't really need this props.loading. I was just checking to see if it's true or false. But essentially this will only show if props.loading is true. So remember in our previous file in the crypto store, I was turning off that loading on and off, that set loader function. So this is what will happen. And I put this in the app view so that way it takes over the whole page and you'll see this loading spinner. So let's see if this all works. Okay, so I ran npm run dev, and here is what it looks like. I'm gonna click connect wallet. It's gonna bring up my little MetaMask, and I'm gonna choose this. This is my test Mumbai network. I only have 3.49 Matic because some of it was taken out while I was deploying the contract. I'm going to connect it. Cool. So right now it says number of entries 0. I haven't entered anything but let's try this out. I'll do hello world and send. So now it's bringing up this Polygon network. You see it's mum by Alchemy. This is 0.5 Ether that I have to send. It's going to come out of my wallet. There's some gas fees that I set. If I confirm it, it's going to take a few seconds. And this just depends on the network. I'm glad I'm using the Alchemy network. It should be a little bit more reliable than if I directly went over. Cool, it says transaction to confirm view on Etherscan. So hello world is there. And by the way, number of entries 0, I don't have any events to update this. But if I refresh it, the page, and I connect the wallet again, cool, it says 1. There's my hello world, awesome. So now I can try it again, test 1, 2, 3. Once again, it's loading, it's bringing up Metamask, confirm. Cool, so it completed here. I have my test 1, 2, 3. I can also click here and it'll actually bring it up an Etherscan. So I can take a look at the different transactions. It'll show me the block time, the network, the hash, everything that looks good for it. Awesome. Occasionally I've noticed while testing this out that it does fail sometimes. And I think that's due to the fact that my gas fees aren't high enough. So sometimes if you don't have high enough gas fees, that it won't accept it. And being on a test network, it's not 100% reliable. I mean, I could play around with the gas fees and change it around, but for this case in this test app, this is fine. So I'd like to hear what you guys think. Leave a comment below if this was helpful. I appreciate it. If you guys like these videos, I definitely do more of them. There is so much to learn in this Web3 space. It's pretty cool. Thanks.